Hey guys, Krosif here with Signals Everywhere, and today I want to teach you how to properly tune in Narrowband FM, Wideband FM, and especially upper and lower sideband, because it seems to be in the community one of the hardest modes for you to actually tune into and receive properly. So I'm going to show you how to do that today, and depending on how my software works out, I'll also be showing you AM, double sideband, and of course CW. So without further ado, let's jump right in. The first signal that we have here is a wideband FM signal. As you can see, it's taking up about 250 kilohertz of bandwidth. If you were to use the narrowband FM, for example, it is far too wide at 12.5 kilohertz up to 32 kilohertz. You're not going to be able to hear that signal properly. And if I go ahead and unmute,
The idea here is to help you tune in signals that you otherwise may have had a hard time.
you can hear that that is extremely muffled. Now, wideband FM is something that you generally run into when you're looking at broadcast FM radio stations. Now, if we switch back over to the WFM mode here, you'll see that we get up to 250 kilohertz of available bandwidth in our passband. So we can narrow this down and we can widen this out. So now if I unmute this, we should hear a much more clear wideband audio signal. So I hope this helped, and I hope you like this track because it's going to be looping throughout the duration of this video. My name is Corrosive, and this is Signals Everywhere. So you can see in my case there is a little bit of background noise to that, and that's really just because I'm recording this on the same PC that's generating the signal, and I'm demodulating on the same PC as well. But that is your wideband audio signal. So now we're going to switch over to a narrowband FM signal so I can show you the differences with that. Now here you can see we have a narrowband FM signal, and if you've noticed, this is much more narrow than a wideband FM or a broadcast FM station. This is the kind of signal you're going to see when you're looking at something like your local police department, taxi services, and things of that nature. What I'm going to do here is just zoom into this signal so we can better see it, and we're going to switch over to the narrow FM mode. So right here you can see I'm at about 32 kilohertz, and I can widen this down to, well, you can go to next to nothing, but traditionally you're going to have about 12.5 kilohertz, 13 kilohertz. That's your average narrowband FM signal. And then there's technically wide FM, which is about 25 kilohertz to 30 kilohertz for some other radio services like the amateur radio band. So if I go ahead and unmute here, we'll hear the narrowband audio coming through.
FM, AM, upper or lower sideband, just to name a couple of modes. And the idea here is to help you tune in signals that you otherwise may have had a hard time tuning into previously. So I hope this helps, and I hope you like this track because it's going to be looping throughout the duration of this video.
And that is a narrow FM signal. So like I said, that's going to be about 12.5 kilohertz up to about 30 kilohertz, depending on the radio service you happen to be in. Here you can see that I've switched things up again. We are now looking at an AM signal, or an amplitude modulated signal. And this is what you're going to see more often than not in the aircraft band. So planes talking to one another, talking to air traffic control, things of that nature is where you're going to hear AM. But you'll also hear it in the shortwave bands as well, and some amateur operators also use this band. So in order to hear it properly, we're going to switch over to the AM mode, and I'll go ahead and unmute the speaker here. My name is Corrosive, and this is Signals Everywhere. What you're listening to is an audio sample that may be in broadcast FM, AM, upper or lower, and we can narrow this a bit as well. A couple of modes. And the idea here is to help you tune in signals that you otherwise may have had a hard time tuning into previously. So I hope this helps. And so that is your AM signal. And so an AM signal, or amplitude modulation, is going to be pretty similar to something like upper and lower sideband. The difference being that lower sideband or upper sideband is only going to be using the upper or lower half of the amplitude modulated band here. Or essentially you would be looking at 1/2 of the signal. So what we're going to do here is I'm going to go ahead and switch over to a lower sideband and then an upper sideband signal, and I can show you how to properly tune those signals in and what they should sound like, as well as what they'll sound like if you happen to be off frequency a little bit. Now here we can see an upper sideband signal. You know this is upper sideband because you can see in the center here, this is where your carrier would traditionally be, and you can see the signal is sloping out to the right, or the upper side of the band. Another good way to look at this is if we happen to be in AM mode, you can see if we put this carrier line here right in the center, that we're on the upper side of this band. And in fact, if I unmute this in AM, you can see what this sounds like.
going to be looping throughout the duration of this video. It is explosive, and this is signals everywhere.
So you can certainly make out a little bit what's being said, but it obviously does not sound correctly, and that's because we're listening to a whole nother half of the band that doesn't exist. So now I'm going to switch to upper sideband. You'll see here that we have just the upper side being covered, and then we can change the bandwidth of this particular signal demodulator, and this is going to change what this sounds like. So let me actually start over here, and I'm going to unmute so you can hear what it sounds like when you're tuning past or tuning over an upper or lower sideband signal.
Tuning into this video.
And that's something that you're going to hear a lot if you're used to HF radio or shortwave receiving. So what we need to do is make sure that this center line here is lined up just against the very left edge of our sideband signal.
And I hope you like this track because it's going to be looping throughout the duration of this video.
My name is Corrosive, and this is Signals Everywhere. What you're listening to is an audio sample that may be in broadcast FM, AM, upper or lower sideband, just to name a couple of modes. And the idea here is to help you tune in signals that you otherwise may have had a hard time tuning into.
And as simple as that, we have now tuned into an upper sideband signal. Now let's go ahead and switch to a lower sideband signal so that you can see the contrast to this particular type of modulation. And here you can see that I have completely flipped the upper sideband signal to a lower sideband signal, and now the signal is existing on the left side of that band. So if I were to switch back to AM, you can see that if I place this right in the center of where that signal would exist, we're on the left sideband of that AM signal. And again, if I were to unmute this, it would sound very garbled.
Going to be looping throughout the duration of this video.
Now we're going to switch to lower sideband, which is our correct modulation. And you can see we can make out what's being said, but my bandwidth is far too narrow, and I'm slightly off frequency, so it doesn't quite sound right. Let's zoom in a little bit. We're going to go ahead and extend the bandwidth here. Now we can hear a little bit more of the fidelity in my voice. However, we're still slightly off frequency, and that's where we get this high pitch. So let's move it slightly over to the right.
Just to name a couple of modes. And the idea here is to help you tune in signals that you otherwise may have had a hard time tuning into previously. So I hope this helps.
And that's about as close as we're going to get. So you can play around with this, but you'll see very quickly that if you're a little bit too far off frequency, you're not going to be able to clearly make out the signal.
And the idea here is to help you tune in signals that you otherwise may have had a hard time tuning into previously. So I hope this helps, and I hope you like.
Now that we've gone over AM, FM, narrow, wide, as well as upper and lower sideband, let me go ahead and show you briefly what a CW signal or a Morse code signal looks like. And so finally we have a CW or a Morse code signal. Now I have to apologize because what you're seeing on the screen is not quite what I wanted to show you for CW. My generation software is not really doing exactly what I want it to, but I still wanted to show you what CW sounds like. So essentially when you're looking at a CW or a Morse code signal, you should see just on-off keying. You'll see where you have this up and down on your waveform. However, it would not have this carrier in the center the whole time. That carrier should only exist when the CW code is actually being keyed. Because of the way that my software is modulating things, it's not coming out that way. But what I can do here is just zoom into this sideband here with our CW demodulator. And I'm just going to capture this one here just so you can hear what CW should sound like properly on your software-defined radio on the receiver. And with that, I hope you guys were able to get something useful out of this video. If I was able to help you guys out, please leave me a like and subscribe to the channel if you'd like to see more content like this. I put out new videos every single week, and I hope to see you guys in the next one.